Hi, welcome to the FoodSense Generation 4 weekly webinar. So we like to do this weekly webinar where we answer technical questions or support clients through this weekly webinar. So I'm just going to dive straight into it and say we're talking about the FoodSense Generation 4, which is sometimes known as the Scoville meter. And in one of its, let's say, iterations, it's used to measure the hotness of chilies. I've actually got the FoodSense Generation 4 in front of me today. Now, ZP, if you're a FoodSense Generation 4 client, we like to support clients by personal online training. If you are a FoodSense Generation 4 customer and you have not received direct online training from ZP, please make sure that happens. We do weekly webinars. This is a weekly webinar. I'm going to talk today about some HPLC data that we've received from South Korea, and we've tested the same samples at our labs, and I will compare those results. You'll see there's a good correlation. And then we also do monthly webinars where we do a much more deeper dive into it. So today's a very specific webinar. I'm going to specifically talk about 4 samples from South Korea that have previously been tested by HPLC. They've then come to us by courier. We've got them out and we've tested them, and we're going to do a correlation or comparison of the results today. Every month we do a much deeper dive into FoodSense Generation 4, and you can attend that. We do 2 on a day, 1 in the morning, 1 in the afternoon. So if you're in South Korea and you're interested in this particular product, for example, come to the morning session. If you're in South America, Central America, or North America, maybe come to the afternoon session, because our time zone means that we can cover both time zones quite nicely. Because our morning is either an afternoon for somebody, or our afternoon is the morning for the next person. So it does work out quite nicely. If you see a link, that link will be underneath the video when I finish. So you can click those links and come to these webinars. So the story here then is that there is 4 samples that have been previously tested at the Korean Agricultural Technology Promotion Agency. So I'm not super familiar with this, but I believe that this is a government agency, and the 4 samples have kind of gone there for testing, and they've come to us. Now, it was a bit hard with the results because the results table we got I don't think it had it in Scoville heat units, but at ZP we've converted it. So sample number 1, we'll use the same sample throughout. So sample number 1 had 12.5 milligrams per 100 grams of capsaicin in it. That's a slightly unusual unit. I can deal with it. We are chemists at ZP, or at least some of us got chemistry background, so we can deal with it, no sweat. But just to say, it is slightly unusual. But it's 12.5 milligrams of capsaicin in 100 grams of the sample. Dihydrocapsaicin, 8.93 milligrams in 100 grams of the sample. The total capsaicin there, therefore, is 21.43. I can add those 2 things together only because capsaicin and dihydrocapsaicin, when the masses are equivalent, then their pungency is equivalent. These 2 isomers of capsaicin have the same pungency, so that means I can add them together when calculating the Scoville heat units. Now, so if I just back up slightly and say, so in that sample 1, it was 12.5 milligrams per 100 grams with 8.93 milligrams of per 100 grams of dihydrocapsaicin. Therefore, the total is 21.43. Just simple arithmetic. And then we've converted milligrams per 100 grams into ppm, and we can do that just by times by 10. So ppm, parts per million, is more usual, let's say, in environmental monitoring and maybe in food monitoring. As a chemist, I don't really like ppm, but there we go. Parts per million. So we've converted the result into parts per million. The reason that we've done that then is because we actually want to get into Scoville heat units, and you can convert 214.3 ppm into Scoville heat units just by timesing by 16. So we get 3,429 Scoville heat units. So sample number 1, 3,429 Scoville heat units. Same process for sample number 2, 4,666. Sample number 3, 21,133. And sample number 4, 53,888. So I've just got a table here where we have just simplified it. We've taken out all the milligrams per 100 grams and all the ppm and just sort of brought it down. So sample 1 is the sort of least pungent, sample 2 is the next pungent, sample 3 and 4 are considerably more pungent than the previous 2, and sample 4 is by far the most pungent with a Scoville heat unit of 53,888. Now, hardware. So I haven't got an image in this slide deck of a high performance liquid chromatography, but it's big. It's big, it's expensive. You have to be really quite skilled to run it. It uses organic solvents. The sample preparation is difficult. So the reason I bring all that up is I kind of want to just segue off and do a quick demonstration just to show you that what we're talking about when we talk about the FoodSense Generation 4 is this technology. I'm going to do is take a chili sensor from this. I'm going to put a chili sensor into this unit, and I'm going to put a pre-prepared sample on this. The only reason I'm doing all this is I want to give you a sense of actually how small, modern, practical, quick to get a result this actual unit is. And I will go to assay, I will start measurement, and off it goes, and that will take about 30 seconds. The reason I bring this up is because we are going to compare ourselves in these slides to high performance liquid chromatography. But of course, if high performance liquid chromatography was an ideal solution for all handlers or all people who are handling chilies, then obviously there would be no problem. But in fact, HPLC is very expensive, is slow. Most people are using third parties to do it. There's no transparency, etc. to it. So I now have my result on my phone. The reason that's significant is because you saw that, admittedly I only ran the test, I didn't prepare the sample, but you can see, and I'll just change cameras for a quick, I get a result on my phone really quickly, and it says upload complete. So I have transparency on this. What I mean by transparency is I can, I'm just going to do a quick refresh of my browser here, which I am doing. And here's my results. So I'm just going to share my screen with you real quick. Here we go. So this is the date today, this is the time today, and this is the operator. And I've got my, in our larger webinars, we absolutely will talk about, when I say my larger webinars, our monthly webinars, we will talk about the significance of this data. But FoodSense Generation 4 is a great technology because A, we get the result, it's easy to use, it's fast, it's much lower cost than HPLC, and it's got great transparency to it. We can absolutely see our signature for this molecule, no problems. I get the result in the cloud, and I get the raw signal, and I get the operator, and I get the time, I get everything. So with that said, I'm going to go back really to the main thrust of this now, which is that's the hardware we've been using in this work. Now, because I think these are chili powders, we've actually got an SOP. So if you have not received the SOP from Zimmer and Peacock on how to run chili powders, please get the SOP from ZP. There's a significant note in that SOP which says we do a rocking or mixing overnight. That's really important. And it's also very important to say that if you've received training from Zimmer and Peacock, you'll understand that when something is mild, when I say mild, something like 5,000 Scoville heat units will do what's called a 1 in 10 dilution. This app will absolutely tell you if you don't get the dilution correct, by the way. If it's medium, and medium is, let's say, 20 to 50,000 Scoville heat units, we'll do a 1 in 100 dilution. It's really important. We really have to emphasize this in the training that we give, but the app will guide you. But if you haven't received training from us, please make sure you get training from us. So the SOP that we've been following is good. The one thing that we've deviated from in the SOP is we haven't done a 1 in 1,000 dilution. We've done a 1 in 10 or 1 in 100 dilution, but I will call that out today. We extracted overnight. We have kind of tightened up our SOP for chili powders, and we do an extraction overnight these days, or 24 hours, because then it makes sure that all the capsaicin comes out. So this is the SOP that we follow. This SOP exists as a PDF. If you're a FoodSense Generation 4 customer and you haven't received it, please make sure that you do receive it. And that's the SOP that we've been following. So these are our results. So Zimmer Peacock, these 4 samples came to us by courier. They came to the facility. We took the sample 1. We knew actually what the Scoville heat unit was, but you don't need to. The app is smart. The app has got an AI in it, and it will know whether you've got the concentration right or wrong. We did a 1 in 10 dilution, and we actually got an average. We did several measurements. We got an average Scoville heat unit of 3,314. So you can appreciate there's not much difference between 3,429 and 3,314. In fact, and our precision, because we did multiple tests, was 14%. So we've got an average of 3,314 and a precision of 14%. Sample number 2, the HPLC said 4,666. We got it at 5,532. I'll talk about that difference in a minute. That difference is about 19%, I believe. We did a 1 in 10 dilution, by the way, and our precision, our repeatability. What you'll notice is you never know the repeatability or the precision of the HPLC system. And you get one sample, one result, no precision. Because precision, you only know precision if you do repetition. And you don't get repetition with HPLC because it takes too long and it's too expensive. Sample number 3, from the HPLC, it was 21,000 Scoville heat units. We did a 1 in 100 dilution. And we got a score of 19,460, which I think is about 8% difference. And our precision was good as well because we had 13%. And then sample number 4, by HPLC, it was 53,888. We did a 1 in 100 dilution. We got 40,920. Our precision is good. It's 13%. So our repeatability, our ability to get the same result. The difference between, I think, those two scores is about 24%. So I'll discuss that at the end. In fact, here I go. So sample number 1, HPLC says, with just one measurement, by the way, 3,429. Our average is 3,314. So our agreement means that we're in 3% of agreement with the HPLC. With sample number 2, the HPLC says it's 4,666 Scoville heat units. We say it's 5,532. Our agreement is within 19% of their result. The sample number 3, the HPLC says it's 21,133. Our instrument, or the G4, says it's 19,460. Our agreement is 8%. Or we're within 8%. And then sample number 4, 53,888 from the HPLC. We said 40,920, so our agreement is 24%. If I average all those agreements, we're basically, our average agreement between us and the HPLC is 4%. So on average, if I average all those numbers up, then I actually get 4%. So that means that most of the time, on average, we're within 4% or within 5%, let's say, of what the HPLC is. So very close here, quite close here, off a bit there and off a bit there. But in general, we're in good agreement. And of course, we've got good precision. So we actually can do multiple tests where the HPLC only does one test. It's expensive, it takes too long, and it means that there's a lot of under-testing. So, in fact, I've just run through it there a bit slower. But I would say that in general, if you've got any questions regarding FoodSense Generation 4, and you are a FoodSense Generation 4 customer and you have not received personal online training, please do. And if you've got any questions for ZP, please don't hesitate to reach out to us. Okay, thanks very much.